This meeting is being recorded.
For problem 31 from chapter 14, we're asked to identify which of these two formulas shown below have the same degree of unsaturation. And if you recall, there are two helpful equations that can be used to justify and quickly determine degree of unsaturation, or also known as hydrogen deficiency index. So we see for just hydrocarbons, we can use this formula on the left, and then when we include nitrogen or halogens, we can use this equation on the right. So let's take a look at this first compound. We know that we can ignore oxygen. That's another trick. So we can just take a look at this equation over here to determine if there is any degree of unsaturation. So we plug in a 3 for N, and we see that we would have 8 hydrogens for that. So this has a HDI equal to 0. This is a saturated hydrocarbon. Let's take a look at this second compound. So now we have chlorine, so we can use our the second equation. So we have 1/2, 2 times 3 plus 2 minus 5 for the hydrogens, minus 1 for the chlorine. We ignore the oxygens. So we see 6 plus 2 is 8, minus 6. Then we end up with 2 times 1/2. So we end up with a degree of unsaturation, or HDI of 1. Next, now we have a nitrogen. We can ignore those oxygens. Let's see how this works. So we'll plug in 1/2, 2 times 3 plus 2, and then minus hydrogens, and we have plus 1 for that nitrogen. So we see 6 plus 2 is 8, minus 5 is 3, plus 1 gives us 4. 4 divided by 2, we see 2 degrees of unsaturation for this compound. And we now have our last structure to take a look at. And this is just a hydrocarbon, so we would plug in 3. We know that we would have 8 if we plugged into the 2n plus 2. So 8 minus 6, that means that there's 2 hydrogens missing. We remove 2 for every degree of unsaturation. So this has an HDI of 1. And we see that this compound here and our C3H6 are the answer to this question. They both have 1 degree of unsaturation.